Hello, congratulations. You've made it to video number 2. 2 of about 150, I think.
Oh,
Okay,
nice.
not that many. I'm Mr. Miller, and
Yadira.
Yeah.
Miss Yadira.
and we're going to talk about multi-step equations today. So, something new. All right, so we're going to start with a couple backtracking examples because after our very first step on these new equations, it's going to end up being backtracking anyway. So we did this in the last video, so we're just going to review 2 examples. So we start by drawing a chart, so like a T-chart. We're starting with x here. On the left, we're describing what we're doing to x. The first thing we're doing is multiplying by 3. And then we're adding 19. And we're supposed to end up with 40. So we're looking for what number makes it true. What number, when you multiply by 3, add 19, will end up giving you 40. Then we work backwards. So we're going to start with 40. We're going to subtract 19. And then we're going to divide by 3. So multiplying by 3. And pretty much undo every step until we get to the beginning. So 40 minus 19 is 21. And then you divide by 3, you get 7. So for this one, x equals 7. All right, Miss Yadira, your turn.
All right, my turn.
Here we go. This one has ugly division, but with backtracking,
Fraction.
no problem.
All right, let's try this.
So no
with
panicking on this.
backtracking.
I don't want to hear anyone say, I don't do those.
We're going to try them right now. Let's see. So we'll start with the t. Okay, now we have the x on top. And then let's see, what happens when we have a fraction? Well, let's do the division.
Yeah, there we go.
7, and then is minus 12 equals to 31.
Right?
So now we're going to backtrack. So we'll bring 31 equals 31 over to the other side. Then because it's negative 12, we want to add.
Right,
Plus
and we
12.
do this step by step. So,
and then instead of division, now it's multiplication.
right, so you do 31 plus 12, hit equals after every step. Then we're going to multiply by 7 and hit equals.
So 31 plus 12 multiply by 7.
Yeah, and we get x equals 301.
301.
And if you substitute that into the equation, it's going to work.
So that's not that bad.
Whoop, you lost your 3.
Uh-oh. There we
Right.
go.
Electronic writing is crazy. All right, so let's move on to the new equation for the day. So these are called multi-step equations, and the way you can recognize them is they have x on both sides. And actually, we can't quite backtrack right away. In order to use backtracking, you have to start with x and describe what happens to it. But here we have 2 x's. So we have to do something first. And what we have to do is cancel one of the x's. So usually we go for the smaller one. So I have 2x and a 4x. Usually cancel the smaller one. It'll still work out if you don't, but you avoid some negatives if you do this. So I'm going to subtract 2x on the left, and I'm going to subtract 2x on the right. Whatever we do to one side, we have to do to the other. And we're going to talk more about this later, this kind of method. But so now we add it all out. 4x minus 7 minus 2x is 2x minus 7. And then on this side, 2x minus 2x is 0. I don't need to write that because we're kind of doing 0 plus 6, which is just 6. Okay, then if you want, we're going to learn kind of the old school methods too, but if you're used to backtracking, then now we can backtrack it. We have it down to 1x here. So we're multiplying by 2, subtracting 7, equals 6. Then we're going to go backwards. We're going to start with 6, add 7, and then divide by 2. 6 plus 7 is 13. You divide by 2, it's 6.5. Remember, decimals are equal to 2, so it's okay. We got a decimal. The answer is 6.5. All right, Miss Yadira's turn.
Another example.
There you go.
All right, so we're adding plus 2x.
Why plus this time?
Uh-oh, because we don't want to end with a negative.
Right, because we're starting with a minus 2x.
Right, minus 2x, and then we want to add plus 2x. We'll bring it to the other side.
I made you lose your concentration.
Yeah, you did.
Yeah, so we're adding 2x on both sides.
Okay.
And then we're okay. So.
All right, so we're adding 2x on both sides.
Right, there you go.
There we go.
We got it. So on the left side,
We'll take this up, it cancels out.
Mhm.
We'll bring the 10 down, equals 2 plus 3x is 5x, and then that's plus 35.
and this is
So
like,
now we can backtrack.
yeah, it's like being back in the old neighborhood, right?
Yeah.
Very familiar.
There we go.
So usually more advanced equations, where we'll do a few things and it gets into an equation we can backtrack. And then actually, eventually we won't even backtrack.
So we have x, and then we're multiplying times 5, and we're adding 35. And that would equals 10.
Okay.
So if we backtrack, that would be equals 10. We are subtracting 35, and now we're dividing 5. So 10 plus 35 is 45 divided by 5 would be,
We're subtracting 35. That's okay, so 10 minus 35, you got it right. 10 minus
10
35.
minus 35, got it, so it's 25.
Negative 25.
Negative 25.
Yeah.
So negative 25. Here.
Very good. And then we're going to divide that
by
5. By 5.
So that would be negative 5.
We did it.
Yay!
X equals negative 5. But no problem. So we just start by canceling a term and then backtracking after that. All right. We have 2 more examples of this, but let's skip one. So are you ready?
Sure.
You want to tackle that one?
Alrighty.
Let's hit the pen there. And we're going to skip A and just do one more example here. So I see a minus 6x and a minus 2x. Which do you think we want to cancel?
Let's cancel minus 6x.
Yeah.
Let's do that.
If you go with the smaller one, you'll avoid negatives. Negative 6 is smaller than negative 2.
So then we'll cancel the larger one.
Yeah.
So plus 6x, both sides. So we know by doing this, we'll cancel this side. Nope, we don't want that no more. That's 100 equals 52. And that would be plus 4x. We'll definitely use backtrack on this one. There we go. We got x times 4 plus 52 equals 100. On the other side, we put 100 minus 52, and then this one is divided by 4.
Okay.
So Mr. Miller, 100 minus 52
is 48.
48.
And
So
then
we got 48 here.
Divide that by 4.
And then we're going to divide this by 4.
And you got it. My answer is 12. Now maybe you can write it down here, x equals 12, because people who are experienced with backtracking know to look there. But if you're not familiar with backtrack, you would know to look up there. So we write the answer.
Equals 12.
Yeah.
Awesome.
All right. Now, I have a feeling this is old news to a lot of people. So we're going to mix in a little geometry. Okay, so on these, we want to know what value of x would make the parameters equal to each other. All right, so first we have to come up with an expression for the perimeter. Remember, perimeter is the distance around. So if this side is x, this side is x also. They have the same marking. If sides have the same marking, they're congruent. So to find a perimeter, we have x plus 26. We simplify that, that's 2x plus 26. Then we have to remember that the opposite sides of rectangles are congruent. So if this is x, that one's x. That's x plus 6. This is x plus 6. And now when we add them, we combine like terms. We have 4 x's being added together. So that's 4x. Then we have 2 6's plus 12. So this is the perimeter of the triangle. This is the perimeter of the rectangle. So 12 there. And now we want to know what value of x makes them equal. So we set them equal to each other. So we said 2x plus 26 equal to 4x plus 12. All right, so we're going to subtract 2x from both sides. And over here we get 26. And this is 2x plus 12. And I'm going to backtrack. Equals 26. So 26 minus 12 divided by 2. 26 minus 12 is 14. Divided by 2. 7. 7 is the number that makes the perimeters equal. All right. We're going to skip the last example, another beautiful one here, but we're going to catch you on the journal assignment. We always catch you with the journal assignment. So please remember to, in your journal, label this as video number 2, so we can, when we check your work, we know what video it is. And these two are multi-step. You have to decide which x term to cancel. Down here, just a little hint, since you only saw this once, remember this side is x also. You're going to find the perimeter of the triangle. Then you're going to find the perimeter of the square. So, since all these are marked the same, they're all x plus 5. So find the perimeter of the triangle, perimeter of the square, and set equal to each other. I think they could do it.
I think they could.
All right. See you next time.